Hello, guys. You know, I'm very, very eager to do another live streaming, and this will be about the NFPA, National Fire Protection Association, Diamond number 704, because it's very important also to prevent any work related injuries and damage of properties and equipment and damage to the environment if the fire and explosion will be happening in a certain work environment, especially when those performing parties that will be able to do hot work activities are not taking care for their safety. And then they did not assess, they did not identify, and they did not evaluate and analyze the different existing and potential hazards and associated risks in this hot work scope of works. So in that way, we can eliminate definitely this fire and explosion. We need to eliminate because this is very disruptive to normal operation. And this is very catastrophic. Okay, if this happens, a lot of people will be suffering through major physical injuries. And in fact, it can cause also losses of life, okay, or death or fatalities or whatever, chupa chuchu. Okay, so I need to discuss this to you in a detailed manner. Oh my gosh, you have an idea already, but before I did not discuss this very detailed, only some basic info, but now I'm trying or managing myself to discuss it in detailed fashion. Okay, wait for a while. I have to, search a little bit in my search. No, another topic for the, I have to review something because I missed something that I have to prove. That's why I told you a while ago, right? I have to validate, okay, sources. That's one way also to double check because I doubt something, then I have to validate. And you just think that I did not do that. I do that really cautiously and honestly. I really verify and validate the information that I already discussed to you. Okay, that's why I told you guys every time I do my live streaming or blogging, then you have to react and you have to object and to note it out that there are errors and mistakes somewhere along the way in my discussion so that I can issue an error statement or whatever. I have to do your apology, blah, 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 so and so. I missed some parts because I cannot achieve all the academic information that I've learned before was already vanished and disappeared because that was 20 years ago. And then my research now would not be enough because I am working now. I'm very busy. I'm not focused on research. I'm not focused on reading. Okay. Okay. After work, only I can research and read a lot, but most of my time I'm in work. Okay. Something like that. I can do other things also, not just only that. Okay. This meaning to say, not really rigid and comprehensive my research methodologies. Gosh, sorry for my tongue. Again, was being twirled. Okay, gosh. Ano talaga ganun? Okay, nagsapit ang dila ni June. Okay, like that. I love to speak in English because, if I will speak Tagalog, mabubulol ako. And then, not really that good. When I speak also in Bisaya, there are deep words I cannot also express well. Okay? That's why I will speak in English because I am, free to discuss it to you spontaneously if I will use English language. And a lot also can understand all over the world, globally, if I will use English language. At least it can grow my audience all over the world, something like that. Because I will use Tagalog, maybe others cannot understand there. And then, in the subtitles, it need helps. But for me, it's okay to speak in an international language, which is English communication. Okay? Like that. And then there are also terms that's very difficult to express or to discuss in Tagalog and Bisaya. For example, amino acid. There's no equivalent Bisaya for that. Okay, so how can I discuss that in Bisaya or in Tagalog? So I could use English all the time, right? For example, what is perspiration? What is crystallization, evaporation? Okay, like that, and a lot of physical and chemical processes and physical and chemical separation processes. Okay, there's a lot. Okay, osmosis, blah blah blah, distillation. Okay. So like that, condensation, humidification, blah, 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 so and so, okay? Like, that's why I use English all the time, okay? Don't call me OA because, you know, this is really my forte, one of my strongest points, okay? That's why, okay? Wait for a while. Oh my gosh. I have to do this. I have to verify the source, okay? Maybe it was wrong. I doubt. Really? Okay. Wait for a while. Give me 5 minutes. I want to verify something. Okay. Okay. Correct. I was in trouble. I need to verify really if I'm speaking the wrong thing. It will be you know, a bad impression to my audience. Though I did a lot of mistakes before, but you know, it's very good to minimize your errors, right? Normally. Okay. Okay. That's correct. Okay. Now we proceed. Oh my gosh. Oh, not yet. Okay, like this. Okay, I have to draw the diamond. Some hearts are diamonds, some hearts are stones. Diamond is a precious stone, right? Like that. And that is a pure element, right? Can be found in the underground surface, in the soil. Am I correct? Pure element, meaning to say that is not being produced through alloying. Alloying meaning alloy combination of different metals, right, to produce this product. Okay, I think so. Just like gold, okay, they are what is that one? Naturally occurring metals. So I think diamond also is an example, or it's already a mixture of something. Anybody, if diamond is a pure element or pure metal or not, or it's already a product of alloying various metals. Chemistry, I think general chemistry, right? But this is more applicable to the mining engineers because it deals with the study of minerals and any substances underground in the soil. Natural element, a pure metal or not? Or it is a product of combination of various metals. Or it is a naturally occurring metals or not? Okay, that's question. Question number one. Oh my gosh. Okay, going back to the main topic. Oh my gosh. Oh, time check brought to you by uh, powdered Alaska milk. Why always powdered Alaska milk? My gosh. There's no other products, always powdered Alaska milk. But because I'm used to. Okay. My gosh. Oh, I have no scratch paper anymore. How can I explain this further? Before talking for this diamond, we need to talk some terminologies that are very necessary for us to understand further this topic. Okay, we proceed to combustible materials. What do you mean by combustible materials? Anybody? Nobody can answer because this is an interactive sharing of information and nobody chat to be in the right corner also. Okay? Okay, so combustible materials are materials that will be easily combust or burned in air. Okay, like that. It's combustible materials. Meaning to say, if there is an ignition source, how can it combust or burn if there are no ignition sources? Okay, common sense. So those are combustible materials. Okay? What are flammable materials? Okay, so there's a difference. Okay, anybody? My gosh. So these are combustible materials that can easily be ignited, okay, in the presence of an ignition source at ambient temperature. And now, Sir Sotero, what is an ambient temperature? In chemistry or in your physics, it is about 20 to 25 degrees Celsius in the range. Okay, but mostly they will refer that as 25 degrees Celsius. But when we speak about ambient temperature, especially in the concept of flammable materials like this, it's basically basing on the air surrounding temperature. Okay, so meaning to say the air surrounding temperature, which is 25 degrees Celsius or at room temperature, okay, it will ignite, something like that, easily ignite. So those are flammable materials. So meaning to say, directly, technically, so those substances that has lower flash points, okay, flash points again. So Sotero, what is flash point? Okay, you need to ask all the time because you know it's connected there. Okay, in the equation. Oh my gosh, equation talaga. Okay, flash point is the lowest temperature of a particular combustible gas or vapor in air that will spontaneously ignite in the presence of ignition source. Meaning to say, there's no flash point if there's no ignition source. Okay, like that. It needs an ignition source to ignite certain substances. Or, in another definition, similarly with each other, it is the lowest temperature at which a particular combustible gas or vapor in air will produce a flash of fire when it contact to ignition sources. When you speak about ignition sources, there's a presence of heat. So automatically, the surrounding is under exothermic reaction, the release of heat. Okay, like that. So flammable materials, when there's a release of heat, it will easily ignite, especially if the flash points are very low. Okay, like that. Okay, what else? The basic information regarding this topic, because this is NFPA 704 OSHA standard, OSHA, based on OSHA standard also. NFPA are agreeing with OSHA standard also, and then linked with, in complementary with the ANSI, American National Standard Institute standards, and also the ICEA, International Safety Equipment Association. That's why in our PPE mandatory requirement, the one who made the standards are the ANSI. Okay, ANSI. Blah, blah. For example, okay, safety shoes. Okay, like that. ANSI, ICEA, Z44, like that. Series of 1999. That's the standard of wearing the mandatory safety shoes. Okay, like that. So there's also an equivalent OSHA standard, something like that. That is 136, 29 CFR 1910.136 standard. Okay, so you should know the standard really. Okay, if you are an OSHA professional, not in a PPE like this, it should be basing on the standards because you can execute properly your function as a safety engineer or a safety officer if you have some knowledge on the standards. Okay, like that. Now, the standards of that also are varying. Okay, it was varied. Okay, from the late 2000 also. Oh my gosh, it was varied. They are following now the ASTM, American Society of Testing Materials, number 2412 and 2413. Okay, that's for safety issues mandatory requirement. Okay, so there are three standards regarding footwear safety protection. It changes because it is incorporated the testing methods of those safety shoes with regards to its puncture resistance, slip resistance, like the test methods are being incorporated there because before they did not consider that one also. Okay, a lot of test methods are being incorporated in the ASTM 2412 and 2413. Okay, like that. So just like this, NFPA 704, our topic, this is really a standard. Okay, but I think there's no new standard for this at this point in time regarding chemicals about this NFPA 704. I don't think so. I did not research yet. But so far, I think there's nothing. Anybody, is there any new safety legislation and safety standards regarding to this NFPA 704 about chemicals or hazardous materials or hazardous substances? Okay, nothing. Okay, it's very interesting with the explosivity property of a certain chemicals that can cause explosion. Okay, like that. So we can determine that by obtaining their LEL value and the UEL value. So what is an LEL value? That is lower explosive limits. Okay, 0 10%. Okay, like that should be in the range, but it's better to achieve a 0% so that there will be no explosion rating of your chemicals. So what is the definition of this LEL? Okay, this is the minimum concentration of a combustible gas or vapor in air that supports combustion, like that. Necessary to support combustion. Meaning to say, there's really already, right? Okay, again and again and again and again. That is a rapid oxidation of a certain fuel under the presence of ignition source that will produce heat, smoke, light, and then the residues, the carbon atom, the black color, or anything. It depends on the composition of the fuel substances. Okay, not only limited to carbon atom. Okay, it could be sulfur atom also. If your hydrocarbon contains also a little bit of sulfur, okay, it depends on the reactant plus the oxygen, rapid oxidation of oxygen in the presence of heat. Again, exothermic reaction for combustion. Okay, like that. That is lower explosive limits. And most of the chemicals are having the lower explosive limits value, the explosion or rating or the explosivity rating. And then this upper explosive limit, the reverse is the maximum concentration of this combustible vapor or gas that will ignite in air, or the reverse. Okay, so it's safer in the UEL, right? Because needs higher concentration. Because the other one, minimum concentration, it will ignite easily. Okay, so we must go on the other one, minimum concentration only, right? Because it's very dangerous to have higher concentration. Normally, it's reacting to other chemical substances also. Okay, the more it is becoming unstable. So if it is unstable more, then it will react vigorously with other chemical substances, right? That's upper exclusive limits. And the other one is lower exclusive limits. And now we go to the various temperature. Okay, temperatures are an indicator when we talk about flammability, okay, characteristics, temperature, because flammability characteristics are that. So we need to study also the 4 basic equations of temperature. What are those? Fahrenheit, Celsius, runtime. Okay, like that. Already told you in my previous about, discussion about chemistry, right? What's that? Degrees Celsius. 5/9 degrees Celsius. Okay, 5/9 times degrees Fahrenheit plus 32. Okay. Again, degrees Celsius is equals to 5/9 times degrees Fahrenheit plus 32. Okay. Degrees Fahrenheit is equals to 9/5 times minus 32. Okay. Minus na siya. Okay. Degrees Fahrenheit is more bigger. Okay. I will show you the equation again. So you can memorize. This is an indicator. That's why it's related to the temperature, flammability, chuba-chuchu, like that. Okay. So we need to this basic temperatures, and also very important, right? Okay, this one degrees Celsius 5/9. Okay, degrees Fahrenheit 10/5. Ganon. Okay. Okay. Degrees Celsius is equal to 5/9 times degrees Fahrenheit minus 32. Bracket, open and close parentheses, bracket, right? In algebra. Okay, degrees Fahrenheit is equals to 9/5 degrees Celsius plus 32. So if we divide 9 by 5, that is 1.8. Or you can state that as 1.8 degrees Celsius plus 32. Okay, Kelvin, letter K. You can make as a capital K, or you can make it as a smaller K. It depends on you. Okay, so degrees Celsius plus 273. Okay, like this. Degrees Celsius plus 273. If you have the value of degrees Celsius, then you have to substitute, and you can obtain the Kelvin. Okay, Rankine. And this is the degrees Rankine. Okay, so 1.8 times, okay, degrees Celsius. Okay, like that. Rankine is equals to 1.8 times Kelvin. Okay. My brain easily think because that's bigger value than Celsius. That's why. And Rankine want to be higher, something like that. So I quickly change to, sometimes you can analyze, sometimes like also like S. Okay. So Rankine is equals to 1.8 times Kelvin. Okay. Like that. These are the 4 equations of temperature of substance or an object. Okay. That's the definition of temperature. Okay, like that. And it is a requirement of the computation of heat. Okay, like that. There's no heat if there's no temperature. Okay, like that. So we will arrive for the formula. Q is equal to mc p dt. Okay, which is the mass of an object and the specific heat capacity of a substance and delta change in temperature. So final temperature minus the initial temperature. Q represents heat. Could it be in BTU per hour like this? Okay, could it be in calorie per hour or joules per second, something like that? Or if you want to eliminate the seconds, multiply that with time. Okay, so that what will left is the unit of energy only. It depends, okay, on the conversion factors. Okay, like this. Q is equals to mcp dt. Okay, mass of the object. Q represents heat. Could either be a positive heat or a negative heat. Okay, like that. It is lower at lower temperature. Okay. At lower temperatures, meaning endothermic reactions or in the endothermic environment. And then for exothermic reaction, exothermic environment or hot environment, something like that. Okay. Q is equals to mcp dt. Cp is the specific heat capacity of water. Okay, times dt, meaning the delta change in temperature, the final temperature minus the initial temperature. Okay, like that. As far as I could remember, the unit of specific, I will prepare this one. This is just on the spot. I don't plan to plug this also. Okay, that is calorie per gram per degree Celsius. I think so. Calorie per gram degree Celsius. Let's try. If we convert the units and it arrived to a certain value, then this is correct. We have to prove only. This is only based on my memory. Okay, if we have the mass, grams times, I suspect that is calorie per gram degree Celsius. Suspect only have because I did not prepare this. dt, so degree Celsius, yes, really. The unit of specific heat capacity is calorie per gram degree Celsius because the grams will be cancelled because of the mass. And the Celsius also will be cancelled because of the temperature. What is being left is the calorie, and calorie is the unit of heat. Basically, heat is one form of energy. Okay, that's why we have metabolism. Due to heat reaction, then there will be a burning of calories or fats inside our body. So there's a process of metabolism, the exothermic reaction. Okay, heat. So heat, thermal heat in our body, natural. Okay, like this through the physiology again, inside our body. Okay, so we clear it, right? It was cancelled. Okay. Okay, that's the power of memory, right? It will return to your brain for how many years if you really understand. Also, sometimes what you memorized. Okay, you can prove it, you can derive it, something like that. Because if you are only purely memorizing, you cannot prove something. Okay, like that. Okay, so that's the power of derivation and proving an equation formula. Okay, there's a lot of formulas I cannot discuss also. Okay, I couldn't remember. Okay, so going back to the definition. Oh my gosh. Now, we are concerned of fire explosion. So there is a point what we call as fire point. What's a fire point? Oh my gosh. It is the lowest temperature at which the vapor will keep on burning even if the ignition source are removed. Okay, very clear. For example, there's a fire. There's no more ignition because it's already stopped, but still the fire is going on. So that is fire point. Okay, that is the point where the vapor is still burning, even though the external source of the ignition source has been removed. Okay, so that is a fire point. Okay, like that. Okay, so basically, unless it's just only an initial stage. Okay, that there is still an ignition source, that the initial stage are very less flame happened, and then you have stopped with the fire. And now we go to the O2 ignition temperature. O2. Some students or some professionals would interpret that this is the same with the flash point. But there is a difference for this. O2 ignition temperature, O2 meaning automatic, okay, right? O2 ignition temperature, or what we called as the kindling point of a substance. Okay, do you remember in your This is physical chemistry. Who are chemical engineers graduate there? Is this physical chemistry or under general chemistry? I forgot also. Oh my gosh. That's why I'm asking because I forgot. Okay. Kindling point of a substance. Okay. So this is the lowest temperature of a combustible gas or vapor in air that will spontaneously ignite under normal atmospheres. Okay, normal atmospheres, even if without ignition source. So this is more critical now. Okay, because there are chemicals like this also. Even though there is ignition source, but it will really ignite. Okay, so like that under normal atmosphere. So what is normal atmosphere? And now we'll need to investigate that one. Okay, normal atmosphere, as you can remember, okay, in every 1 mole of gas in a space, it will occupy 24.4 liters standard at STP, standard temperature and pressure. That is ideal gas law. Okay. Oh, no, that's not ideal gas. So that's under Dalton's law of partial pressure. Okay, like that. So in every 1 mole of a certain gas, it will occupy 24.4 liters under STP or standard temperature and pressure. So what are those temperature? Okay, the pressure will be zero. Oh, no, sorry. The temperature is 0 degrees Celsius. Okay. Quickly think again because it's impossible for the pressure will be zero, right? So you will back up immediately with analysis, okay, if you got wrong, something like that. So P is equals to 1 atmosphere. So this is at STP, okay, standard temperature and pressure in Dalton's law of partial pressure. Or not only in Dalton's law of partial pressure, it's only with ideal gas law, the PT and RT, right? I discussed that already a while ago in my previous bloggings, right? In my live streaming. Oh my gosh. Okay, like that. Okay.
The Bluetooth device is ready to pair.
Okay.
The Bluetooth device is connected successfully.
It's a miracle. Oh my gosh. Okay. Standard temperature and pressure is just the same with normal atmosphere. Okay, at 7 degrees Celsius, atmosphere like that. So meaning it will ignite. Okay, so this auto-ignition temperature and kindling point of a substance. Okay, in a certain examination also, they will just put like this a question. Blank is a kindling point of a substance. A, fire point. B, flash point. C, density. D, auto-ignition temperature. So your answer will be auto-ignition temperature. Sometimes there are examinations like that, only very quick testing on your memorization capability and with comprehension or better understanding. Okay, something like that. Okay, normally in physical and chemical principles. Okay, in day 2 board examination of Bachelor of Science Chemical Engineering, usually like that theory. Okay, like that. Okay, so and now if there is an auto ignition temperature, we have auto ignition temperature. So what is this? Oh my gosh. This is the lowest temperature of a combustible gas or vapor in air that forms combustion. Okay, combustion or necessary to produce a combustion. This is only ignition, meaning this is not automatic, meaning there's an ignition source. Okay, like that. Okay, very clear. Those are the terminologies so that we can understand properly for the for the terminologies or the hazards rating of the diamond NFA 704. Okay, like that. Okay. Actually, in the Nepomuceno examination, it comes out also this kind of question. I remember, and then like this, blah blah blah, and I draw the diamond like that. So thanks God, and then it adds scores for me. Okay, it really come out in the national examination of Board and Occupational Safety and Health International Examination for International General Certification of Safety Professionals, something like that. Okay, because if it is related to chemicals, okay, it's really it's my expertise. At that time also, I was lucky. There are a lot of regarding hazardous communication regarding chemicals, especially the process safety management. So many questions like that, then I can really relate. Okay, Remember process safety management under 29 CFR 1910 number 119. Okay, like that. There's a lot to be considered also there. Considering the input, the output, the process, and what are the things to do in order to avoid those associated risks. For example, the hazards of the bursting of the vessels or the tank. Then you have to consider the parameters. Could it be the flow, okay, the flow rate, the concentration, the velocity, the diameter of the pipe, something like that. Those are the parameters, right? The temperature, the volume, the pressure, like this, the flow rate, the concentration. Then you have to involve that one. So that's the time the hazards will come in. Hazards operability. Hazards operability. It's just like a risk assessment and a job hazards analysis, but the application is more on the process. Okay, so process, job hazards analysis, or
No battery.
we will call that for that we will call that as a hazards operability. Okay,
No battery.
for the equipment
The Bluetooth device is ready to pair.
because I need to
The
intensify.
Bluetooth device is connected successfully.
Okay, going back na lang ta because if you're talking too much, but
No battery.
if that is really related, okay, that's why I'm talking it to you because it's really related to the discussion with this. Okay,
No
my
battery.
gosh, health hazards. Mag-draw sa kong diamond. Oh, in fairness. Oh, like this. And I don't have colors to illustrate the red, the yellow, the white. My gosh. Right? This is diamond. Some hearts are diamond, some hearts are stones. Subdivided into 4 diamonds also, right? 1, 2, 3. There is 1 diamond in the outer layer, and there are 4 diamonds in the inner layer. Okay? Like that. Then red, white, yellow. Okay. Okay, and the yellow. Okay, blue. Actually, it depends on the orientation, because as long as it's gonna be like that, because there's a perfect orientation in the tank. We don't know if the blue is be here. It's just only a representation. As long as you understand the concept behind, because sometimes the blue will be here, the red will be here. It depends on the drawing, but the important point is the concept. Okay, the information. Okay, that would not matter. It will interchange somewhere along the way, right? Okay. Oh my gosh, yellow. I love yellow. The one portion. My gosh, the anti-government political party in the Philippines is yellow. Delawan. Okay, going this. Yellow refers to instability. Instability, meaning unreactive, right? Instability. Just like incapable. So this is IN meaning bad or not capable of doing those things. Incapable is the same with instability. So not capable of doing stabilization of the reaction, right? Because of in. Just like complete, incomplete. Okay? Capable, incapable. Okay? So stable, unstable. There's no unstable but unstable. Then we have to have instability for that. Wrong grammar if you put unstable, that's unstable. So there's also a grammar utilization for that pala. Okay, that's how I found. Oh my gosh, you will never say unstable, right? But you will say instability. Okay, so it will deviate to the usual, which is incapable, incomplete, like that, and instability. So there is unstable, of course. Okay, like that. So okay, not capable of doing stabilization reaction or not stable, right? Instability. Okay, or if it is unstable, meaning it will not react. Unreactive or non-reactive. Okay. Non-reactive. Just like inert gases and noble gases. Okay? Non-reactive. What are those? Neon, xenon, krypton, argon on the last part. Those are noble gases in the periodic table. Okay? This will not react to oxygen. Okay? Or any other substances. Non-reactive. In the chemical reaction, if you try not to add, if you remember the discussion about different type of chemical reactions, it will never really react. There's no such neon dioxide, no, because that is unreactive. Okay, like that. That's the rule. Okay, you wonder why there's no like, for example, argon carbonate. It will never do that because there's a rule for that. They will never react. Okay, because they are highly stable. Okay, that's why non-reactive. Okay, or we can say this as reactivity only, right? Reactivity or instability, no problem. Okay. So zero, when the rating is zero in the tank, what I mean in the fuel tank, you know the fuel tank? In a truck, there's a drawing there. If you notice that one, if you're working in a certain chemical company or whatever, chuba chuchu, that delivers fuel or crude oil in your plant, observe the diamond there. It's reflected there really, the ratings. If the rating is zero, that means that is unstable. Okay. Again, if the rating is zero, that is reactive. Oh, sorry, this reactive meaning that is unstable. Sometimes you will be confused, right? Okay, because others will say if it is stable, it is reactive. No, it's the reverse. Okay? If it is unstable, meaning it is reactive. You think, right, properly, because sometimes you will confuse. Me also confused. Just now, I'm confused. Okay, even though I'm chemical, but still I'm confused right now at the moment. Okay, so unstable meaning it is reactive. Okay, okay, like this. Zero. If you see zero, meaning it is reactive. Okay. One. What is one? Okay. One. It is unstable when heated. Okay, unstable when heated. Meaning reactive when heated. Okay. And you know what is heat already? Already discussed several times, right? Okay. When two, this is referring to the numbers that you found on that color. In two, there will be a violent chemical reaction. If you contact that to other substances, it will produce a violent chemical reaction or vigorous chemical reaction, meaning it is really reactive. Okay? So, produce violent chemical reaction. Violent talaga siya ha, in fairness. Ganun yun. Basta two. Oh my gosh. When three, this is hazard rating. Okay. When three, it will have shock and heat. Shock. What are those shock? Electrical shock, like this, or thermal shock. It depends. Shock plus heat, then it will detonate, may detonate, meaning it will be exploding or has a chance to explode, okay, to other substances or to the presence of an ignition source, okay, may detonate, okay, like this, okay. Number four is the critical one, really may detonate or may explode, no, even though there's no shock and heat. Imagine, so this is the very worst rating, number four. So, may explode and may detonate. Okay? Okay. Meaning to say, normally it will explode at a lower flash points, right? Okay. Like this. So this is the ratings for the instability and reactivity. Okay? Like that. Okay. So, I doubt. Wait. I will review. 4 may explode and detonate. 3, based on my understanding and comprehension, shock and it may detonate. 2, van can okay. 1, stable when heated, so meaning it will react. 0 is reactive and stable. No, it's not. See, I told you. Okay, this is stable already, meaning unreactive. Because it is 0. See, that's the power of comprehensive. You have to review. Okay. Like this, stable and reactive. So this is the power of memorization, and then you have to understand. Okay, stable and unreactive. Okay, because if you will just depend on that memorization plane, then you will be wrong, especially in an examination. Okay, you have to troubleshoot really what you write. Okay, then the power of your what do you call this one, hormone in your brain. I forgot hormone. Okay, talaga. Stable meaning unreactive. Okay? The more it is stable, the more it will not react anymore because stable ka na eh. So just like me, I have so much money. I will never want to do business anymore because I have so much money in the bank already. Something like that. So I am stable already. So no need to do other things. Okay? So I am stable, meaning I am no longer reactive to other certain business out there because I'm already stable. Even though without business, I can still stand up for survival. So just like that in the context of financial management, it's just like the same in the chemical point of view. So I am stable. So let's say I am krypton. Example, I am a krypton element. So I am very stable. So I will not react to anybody else. So I am unreactive. So meaning I am inert. Okay. So 0 hazards rating. Oh my gosh. Really? Red. My gosh, fire hazards. Okay. Fire hazards. Okay. Like that. 0. What is 0? So non-flammable. Obvious, right? Non-flammable. 1. With flash points above 200 degrees Celsius. Okay. Flash points above 200 degrees Celsius. 2. With flash points below 200 degrees, below 100 degrees Celsius. 4. With flash points with 73 degrees Celsius below. So the more the flash points will becoming lesser, the more it will become danger to cause flammability. Okay? Extremely flammable if it is below 700 degrees Fahrenheit flash point. Okay? Like that. So 1, high flammability only. Like that, above 200 degrees flash point. But below 100 degrees Celsius, flammability or flash points, then it is highly flammable already, like this. Okay, the more it will become, the value will become lower. So that's the flash point. The more it will become flammable. Okay? For example, 180, 73, the more it will become flammable because that is flash points. Lowest temperature siya eh, as I discussed a while ago, right? Okay, very clear. No need to expand more. Okay, that's fire hazards or flammability ratings. Okay, now we go to white or blue. Blue muna tayo. Okay, for blue, the 0 is non-hazardous, okay, or non-toxic. Okay, those that are being transported are safe to the environment or safe to the people because 0, non-hazardous and non-toxic. If 1, slightly toxic, okay, or slightly hazardous, okay. If 2, ratings, if 2, it is toxic and hazardous, okay, like this. Under 3, this is very danger already, very danger to human health. Okay, very danger to human health. It can cause, could it be an acute diseases or a chronic diseases? Okay, cancers, whatever, inflammation to the organs in our body. So this is very dangerous to human health. Okay, number 4, that is now fatal or deadly. Okay, that kind of chemicals that put in the tank or whatever because there's a diamond. Okay, fatal or deadly. This is the hazard rating. Okay, like this. No, my penmanship are very dirty. Represents the specific hazards, meaning For example, corrosivity, how corrosive the chemicals really is. Okay, because if it is corrosive, it can cause, irritation of your skin due to the process of skin absorption. Okay, it can cause burns, first degree burns, second degree burns, like that. And it can cause the most difficult, the most dangerous one is the dermatitis. Okay, that's corrosivity. Okay, or corrosive. If it is corrosive or not. So, okay, and if it is inside the tank, they will just put acid also, capital A, capital C, capital I, capital D. Okay, if it is alkaline, they will put the three letters A, L, and K only for the alkaline. Okay, like that. And then if that is really exclusive to water, it can cause explosion, then we'll put W, and there's underline in the center of the W, this one. Okay, if you see like this in the tank W and then there's underline, meaning to say it is very dangerous to water. If it will react to water, it can cause explosion. Okay, this is no water can, like this. Radioactive. This is the symbol of radioactive, like this. Okay, it shows that the chemicals inside the tank are highly radioactive. Okay, and you know already the effect of radioactive materials, right? It can cause, unproductivity in your organ, like sex organ, like that. And then for the lungs, cancers, blah, 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 chu, 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 or chronic diseases. Okay, you don't need to explain further. Okay, like that. So this is for the white. Finished, right? Red, yellow, blue, and white. Okay, so this one. Finish for the NFPO 700 for discussion. Any questions so far? Okay, for this hazardous chemicals and hazardous substances, basing on the hazardous rating, according to the National Fire Protection Association number 704 standard. Basing also in the hazardous communication standard, the parent standard for this HAZCOM communication standard, equivalent. So in OSHA, they will just put capital H, capital C, capital S. Again, capital H, capital C, capital 29 Code of Federal Regulation called as Hazardous Communication Standard in OSHA. Okay, this dealing with chemicals, hazardous chemicals and hazardous substances. Okay, and there it's being declared there the role and the significance and the importance of safety data sheets. Okay, because these four are being discussed also there. Okay, like that. The accidental release in terms of fire prevention, like this. Okay, to do in terms of also discuss the safety data sheets also. But very quick, not too long. Okay.